sulfur, chlorine, argon, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and then there's zinc. Here, let me
And what
write
am
them.
I looking at right here?
That's dihydrogen monoxide, or you could just call it water. That's what
What?
you drink every day.
Why is it called dihydrogen?
Because it has two hydrogens, and monoxide is because there's one oxygen.
Yes, ma'am.
That's why there's a mon in it. This is the abbreviation for zinc.
Thank you. Say this to Rosemary. Always,
Well, I'm gonna ask you something
never
else.
alone.
Why did you draw that arrow? These arrows.
Because it's because like this is what that is,
Dad's probably going to bring
and
the
that's
party.
sodium, and that's chlorine. As you can see from here, sodium and chlorine.
Very good. So, positives and negatives. What do? Do they attract or do they repel?
They attract.
Very good.
So that's why I didn't need to draw lines like I did with. Oh, I didn't draw that yet.
Very good, ma'am. Physics.
Yeah, back to physics. So I just represented the Higgs boson with a, you could call it a quantum fluid, even though it's not, but it's a quantum fluid of sorts, and it pushes on other things harder than it does. It pushes on some things harder than other things. The photon moves through it the fastest because it has a mass of 0. But air moves through it pretty quickly too because depending on how much air you have, it can be pretty light to pretty heavy. And then things like buildings would move through it very slowly. Then there's the W and Z bosons. The W boson emphasizes the weak force with either a positive or a negative charge. The Z boson does the same thing except without any charges. The photon represents electromagnetism.
Please, hate the interruption, but here's some deodorant or something over
Y'all go get that. Somebody go
that
get
needs
that.
to be packed in kids stuff.
Get that deal over, Mrs. Johnson.
Just put it in one of the side pockets. It has a spin of 1, charge of 0, and mass of 0, so it can move at the speed of light, and it's what influences electricity. It's also why light is delayed, and you can see backwards in time, but just by looking farther back,
Can you show
farther
me
away.
where's your experimental design of the rocket?
I'm almost there. And
Okay,
then
yes, sir.
there's the gluon. It emphasizes the strong force by tying together quarks. By tying together all of these different quarks, except for the strange quarks. Strange quarks are the awkward kids. And it ties together the antimatter quarks. And the leptons just fly around outside, so they're not really a part of the nuclear forces. Then I have my theories. I think that the Higgs boson could be equal to a graviton because when something has more mass, it also has more gravity, and it's pulled towards the local major gravity body with more force. Axions could be a thing. They could be dark matter, and they could be another force of photons. These could also be equal to gravitons, the theoretical particle of gravity.
And what about your membrane theory?
Well, I'm about to get
Sorry,
to get
I'm
there.
moving a little
Then there's
fast.
string theory, 11 dimensions. It has it means that every single particle is just a one-dimensional string that vibrates at different intervals and at different intensities. And then the brain theory, it's pretty much the same thing as the string theory, but instead of vibrations, it's how the brains interlace. And the 4 fundamental forces are gravity, electromagnetism, the strong force, and the weak force. Now